Hello guys, back to the class. This is your Stay. Today we are going to discuss about a few more concepts from the basics of thermodynamics. In that point of view, the main objective of this lecture is we are going to focus on first one is the point and path functions. How we are define the point and path functions, and after that what are the differences between point and path functions. After completion of this concept, we are going to learn another one, zeroth law of thermodynamics. With the help of zeroth law of thermodynamics, what we are going to learn from this concept. Finally, we are going to focus on temperature scales, how the temperature scales are divided and which type of scales are used in the industries. So these concepts we are going to learn from this lecture. Let's start with the first one, point and path functions. A point functions is defined as which can be represented by points on a coordinate system. They are called as the point functions. Let's see the point functions here. The properties whose values depend on end states only, and these consists of exact or perfect differential. The best examples for a point functions are pressure, temperature, volume. So these are which are depend upon the end states. Simply they are called the point functions. Let's see the path functions. The identities which cannot be represented by a point can be represented by a area in a coordinate system. Simply they are defined as the path functions. The path functions are depend upon the path of the process, and these are inexact differentials. The best example for path functions, work and heat. With the help of graphical representation, it is easy to understand the point and path functions. Let's see some graphical representation about this concept. This diagram indicates the point functions. If you find out, we are consider the two coordinates. One is the y-axis and another one is the x-axis. In y-axis we are consider pressure. In x-axis we are consider volume. If you find out here, with the help of these two states, we can easily define the point functions, because in that point functions it is the mandatory to know the two end states. In case of path functions, we are consider same coordinate system, pressure and volume. Here it is the mandatory to know the path. So which way the process takes that path. Let us consider one example. Between the state 1 to state 2, some amount of work developed here. If you find out here how much amount of work is developed, how we are defined here, between the state 1 to state 2, what is the region under the path region, we are defined the how much amount of done here. So that's why the path functions are defined with the help of the path is formed, that is the mandatory. So this is about the point and path functions. Next we are going to discuss about the differences between point and path functions. The first difference here is its values are based on the state of the system. We are already discussed the point functions are defined with the help of state of the systems. In case of path functions, the values are based on the how the particular thermodynamic state is achieved. That means these are depend upon the path of the system. And next one is the no matter by which process the state is obtained, its values will always remain the same. In the point function, we are not giving the preference for the process. We are only giving the state points, because there is a no change throughout the process. In case of path function, different process to be obtained, a particular state will give us different values. So in case of path function, we are giving the importance for that process, because in each process we get the or we obtain the different type of values. So this is about the second difference between point and path function. Go to the next one. In point functions, only initial and final states of the process are sufficient. In case of path function, we need to know exact path followed by the process. And fourth one, its values are independent of the path followed. In case of path function, its values are depend on the path followed. So we are already discussed, we are already know, in case of point functions we are giving the importance of only states, not for the path. In case of path function, we are giving the importance for path, because based on that path we define that proper way of the process. And fifth one, it is an exact or perfect differential. The point functions are get the exact or perfect differentials. In case of path function, these are not giving the exact or imperfect differentials. So when we are doing the differentiate between the initial and final state for point functions, we get the exact differential. In case of path function, we are not obtained that one. So this is about the fifth difference between point and path functions. And next difference is its cyclic integral is always 0. For the point functions, the cyclic integral difference we get the always 0. In case of path functions, the cyclic integral may or may not be 0. And seventh one, it's property of the system. The point functions are the property of the system, but path functions are not the property of the system. And finally, the best example for the point functions are density, enthalpy, internal energy, entropy, etc., and including all general properties like a pressure, volume and temperature. In case of path function, the best example are heat and work are the best example for path functions. So this is about the path functions, and next we are going to discuss about one more important concept, that is the zeroth law of thermodynamics. The zeroth law of thermodynamics provides the concept of temperature. Let's see the statement of zeroth law. When a body A is in thermal equilibrium with body B, and body B is in thermal equilibrium with body C separately, then body A and body C are in thermal equilibrium. So it is the statement for zeroth law of thermodynamics. Before we are going to discuss about the concept of zeroth law, it's better to see one general example to understand the concept of zeroth law of thermodynamics. With the help of that example, I will hope you it is easy to understand this concept. Let's see the example. It is not a subject related example, it is only for your understand oriented. Let's see, here I am considered three persons, giving the names for person A, person B and person C. If we find out here, when we are applying the electrical shock for person A, what happened here? The electrical shock equally distributed to person B. From the person B, that same amount of electrical shock is distributed to person C. If we find out here, we have a connection between person A and person B, and as well as person B to person C, but we doesn't have any connection between person A to person C. But here, how much amount of electrical shock we are transferred to person A, that is equally transferred to person C. Here there is no relation between person A and person C. So this is defined the zeroth law of thermodynamics. Let's see, here person A and person B have equality of shock, and as well as person B and person C have equality of shock. Similarly, person A and person C are also in equality of electrical shock. So this is defined the zeroth law of thermodynamics. Now look into the zeroth law of thermodynamics. Here what we have discussed the statement of zeroth law of thermodynamics. Here I am consider body A, body B and body C. From the statement of zeroth law, body A and body B are in thermal equilibrium, and body B, body C are in thermal equilibrium separately, then body A and body C are in thermal equilibrium. We know the thermal equilibrium. The temperature is constant throughout the system. That type of system is called in thermal equilibrium. So similarly, if we find out here, when body A and body B have equal temperature, then body B and body C are in equal temperature, and finally body A and body C are also in consists of equal temperature. So this is about the zeroth law of thermodynamics. And next we are going to discuss about the temperature scales. The temperature scales are designed to measure the temperature in different conditions. Generally, these are assigning numerical values to certain reciprocal states. These are customized to use the two fixed points. They are, one is the ice point and another one is the steam point. Let's see what is the ice point. Ice point is the equilibrium temperature of ice with air saturated water at a pressure of 101.325 kilopascal, which is assigned a value of 0 degrees centigrade. And next one is the steam point. It is the point where a mixture of liquid water and water vapor without considering air. So that's why based on these 2 points we are using the temperature scales. First one is the ice point, it is also known as freezing point, and another one is the steam point, it is also known as the, in applications point of view, generally we are using two different type of scales. One is the Celsius scale and another one is the Kelvin scale, and rarely we are prefer the Fahrenheit scale. So if you find out here Celsius and Kelvin scale, in Celsius scale we are prefer the absolute 0 point at minus 273.15 degrees centigrade. In case of Kelvin scale, we are shown that the absolute 0 point at 0 kelvins. Here what is the absolute 0? That absolute 0 is the lowest possible temperature where nothing could be colder and no heat energy remain in a substance. It means in any substance where the lowest possible temperature is developed without a cool and as well as the without heat energy in that substance. So that is defined the absolute 0 point. And next we are going to discuss about the freezing or ice point. In case of Celsius scale, we are shown at 0 degrees centigrade indicates the freezing point or ice point. In case of Kelvin scale, 273 Kelvin indicates the ice or maybe freezing point. And next one is the water boiling or maybe steam point. For Celsius scale, that steam point or maybe boiling point indicates 100 degrees centigrade. In case of Kelvin scale, it indicates at 373 Kelvin, indicates the water boiling point. These are the different type of temperature scales which are we are using in our regular life based on the need of the temperature condition. So this is about the today class. In the next class we are going to discuss about another important concept in thermodynamics. If you have any queries regarding this lecture, please comment in comment box, and thank you for your watching.